In an earlier chapter in trigonometry, we talked about vectors, and at that time we talked about what was called the geometric approaches to vectors, and that was to help us to draw our vectors in our application problems. And that's where we were introduced to something called the head-to-tail method and the parallelogram method, and a resultant when we drew two vectors, how we would draw the resultant vector of those two vectors, and so on. Well, in section 7.5, we're once again going to talk about vectors, but in this particular section, we're going to be interested in really just algebraic approaches to them. So to begin with, I'm going to talk about something that you may or may not have had before, and that's something called unit vectors. Unit vector is breaking a vector down into its horizontal and vertical components. A horizontal vector that has magnitude 1 is called the unit horizontal vector. And usually we use a lowercase I to stand for the unit horizontal vector. A unit vector that is vertical, so it's a vector that has magnitude 1 and is vertical, is called the unit vertical vector. And that's usually denoted with a lowercase j. So we can take a vector and we can rewrite it in its horizontal and vertical unit vectors. It will be a certain number of i's, a certain number of horizontal vectors, unit vectors, vectors magnitude 1, and a certain number of j's, a certain number of vertical vector unit vectors. Let's take a look at what this might mean. So here I have a point 3, 4. So if I was to plot that point 3, 4 over 3 and up 4, if I now draw the vector that connects that from the origin to that point, so from the origin to that point would look like this. The arrow would be right here because I went from the origin to that point. And as you can see, let me take that off there. I can see I've plotted that in the wrong place, so I'm going to take that off. So I went over 3 and up 4, and I'll draw that one in. I apologize for that. So we went over 3 horizontally, so this right here would be 3 of the i's, and then we went up 4, so we went 4 of the j's. So if we express it in terms of its unit vectors, it would be 3 of the i's plus 4 of the j's. And that's what it means to express it in terms of its unit vectors. 3 horizontal units, 1, 2, 3. 4 vertical units, so 4j. I'm sure you're not going to have any trouble with that. We're also going to talk about the magnitude of a vector again, and just to remind you, the magnitude refers to the length. If it's in this unit vector form, and this one is in unit vector form, we can find the magnitude of v, which is sometimes denoted like this, or sometimes it looks like an absolute value. It's the square root of the horizontal vector squared plus the vertical vector squared. So that would be the square root of 36 plus 64, so that's the square root of 100. So that comes out to be just 10. Now this second one is written in a slightly different form. This is called component vector form. In the component vector form, the first number is the horizontals, and the second number is the verticals. So we would still find the magnitude in the same manner. It would be the square root of 5 squared plus negative 12 squared, and 5 squared plus negative 12 squared comes out to be 169. So I have the square root of 169. So our magnitude is 13. So that's how we calculate magnitude. Again, I don't expect you to have any trouble calculating magnitude. You will have to know how to do this. It's really just the Pythagorean theorem repurposed. Now in this one, they actually describe a vector for us. They tell us that the vector v has its tail at the origin, and it makes a 35-degree angle with the positive x-axis. So if I was to draw my coordinate plane here, here's my x and here's my y, the vector that I'm talking about here makes a 35-degree angle with the positive x-axis. So this is the vector I'm speaking of. And the magnitude is 12. And they want me to find the unit horizontal vector. So they want me to find out how much I want to cross like this. That would be the I. And they want me to find the vertical. So they want me to find this. That would be the j. So to find the horizontal, I can use right triangle trig. So I would say the cosine of 35 degrees equals the I, sometimes we can just call that x, divided by 12. So the xi would come out to be, and it's to the nearest tenth, 12 times the cosine of 35. So I have 9.8. So I have 9.8 I. And the vertical, which again is sometimes just called the y, I could find by using sine. Sine of 35 would be equal to the y over 12. So the y, 12 times sine of 35, 6.9. So I have 6.9 j. So my answer would be 9.8 I plus 6.9 j. Again, we've done problems very similar to this. We just called them horizontal and vertical components. Now we're referring to them as unit vector horizontal and unit vector vertical. Addition and subtraction. Addition and subtraction in unit vector form means that we add or subtract the horizontals together. So for example, if I'm taking u plus v, I would take 6 plus negative 3 for my I, and then 2 plus 5 for my j. So I get 3i plus 7j. Very straightforward. Subtraction is very similar to that. So for the subtraction, now notice the order is important. So for u minus v, I'm taking the 6 minus the 3 times the I plus the 2 minus the negative 5 times the j. So I would end up with 3i plus 7j. Because once again, the order is important. Scalar multiple. Scalar means a quantity that is not a vector. So to multiply by a scalar, we multiply each component by the scalar. So 4 times v would be 4 times 2 in the I plus 4 times 3 in the j. So I get 8i plus 12j. You just essentially distribute the scalar. Sometimes we'll combine scalar multiplication with addition or subtraction. So this time, I'm taking 3u plus 2v. Or I'm sorry, minus 2v. Let's do the 3u first. 3u would be 3 times 3 for the I, plus 3 times 5 for the j. So 3u is 9i plus 15j. 2v. 2v would be 2 times negative 2 for the I, plus 2 times 7 for the j. So 2v would be negative 4i plus 14j. And then finally, 3u minus 2v would be 9 minus 2 for the I, plus 15 minus 14 for the j. So I get 7i plus 1j. So it's best to do it in parts. 3 times the u, 9i plus 15j. 2 times the v, negative 4i and 14j. Oh, just 1 second here. I see a mistake. So I'm going to go back and fix that right now. So it would have been 9i minus negative 4. So that comes out to be a 13i plus 1j. Because I have to use those values. 9 minus a minus 4. Okay? Dot product. Now, a dot product is actually a form of vector multiplication that results in a scalar for the answer. And what we do is we multiply the horizontal components, and then we multiply the vertical components, and then we add those values together. Let's see what it looks like in practice here then. So if I'm doing u dot v, I have to multiply 3 times 2 and then add 4 times 5. 6 plus 20, I get 26. The reason we do this particular type of vector multiplication is this is important in calculating the angle between two vectors. And here is the formula for calculating the area between two vectors. We need to know the dot product. And on the bottom we need the product of the magnitudes. Now, one thing that's handy to know is if the dot product is 0, then the vectors have to be perpendicular. Because the cosine of 90 is 0, so if the dot product is 0, meaning the top of the fraction is 0, then the angle itself has to be 90 degrees. Let's try one of these problems. So here we're looking for the angle between these two vectors. We need the dot product. So we need u dot v. That's going to be 6 times negative 1 plus negative 1 times 4. The dot product would be negative 6 and negative 4 is negative 10. Okay. We also need the magnitudes. So the magnitude of u, the square root 6 squared plus negative 1 squared. Magnitude of u comes out to be square root of 37. Magnitude of v, square root negative 1 squared plus 4 squared. Magnitude of v, square root of 17. And now we put it into this formula. So we take all of this information and we put it into this formula. The cosine of the angle between those vectors would be equal to negative 10 divided by square root of 37 times square root of 17. And keep in mind when we put this in the calculator, we'll need to put all of this bottom in a grouping symbol. So the angle between the two vectors would actually be the inverse cosine of negative 10 divided by square root of 37 times square root of 17. So my angle theta comes out to be inverse cosine negative 10 divided by, since both are beneath a radical sign, I could just put them both beneath the same radical sign. To the nearest tenth, I get 113.5 degrees. That would be the angle between those two vectors. So to calculate that, the two things we needed to know were the dot product, 6 times the negative 1 times 4. Added those together, got negative 10. The magnitudes, square root of 6 squared plus negative 1 squared, square root of 37. Magnitude of v, square root of negative 1 squared plus 4 squared, square root of 17. Plugged it into the formula. Inverse cosine gives us our answer. Okay. Algebraic approach to vectors, not a